Good morning. Welcome to today's class. Let's go over today's lesson plan. We are going to discuss about alcohols today. To discuss alcohols, we need to first make sure that we understand what makes a compound an alcohol, how to name the alcohols according to the IUPAC rules, and some of the fundamental properties of alcohol that may affect their naming. In order for us to go over those, we will take the following steps today. We will first review a few PowerPoint presentation slides as usual. Then we will watch a video that will reestablish the concept that we learned from the PowerPoint presentation. And then we will complete an in-class assignment. You will be choosing a partner to complete the assignment with, and as usual, I will be going around the classroom to assure that you are all on the right track, and I will provide my assistance and help as or when or if you need that. First of all, why are we interested in alcohols? Alcohols are all around us in various forms and serving various purposes. For example, here I have a picture where it shows that alcohol made out of corn are used in gasoline that helps us drive our vehicles. Besides that, as you may recall, that alcohol is in our household products. For example, rubbing alcohol. So alcohol is an important compound for us to know about. Let's talk about the structure and bonding of alcohols. So what makes a compound an alcohol? If a compound has the hydroxy or OH group in it, and it is bonded to an sp3 hybridized carbon atom, then the compound is called an alcohol. And they're classified according to the number of alkyl groups attached to the carbon that also holds the hydroxy or the OH group. For example, the picture or the diagram below to the left, it shows that a hydroxy group is attached to one carbon atom. So if we know that this carbon atom represented a methane before the hydroxy group was attached to it, it would be called a methanol, and we'll learn about naming that soon. And that is one of the simplest alcohol that we can find. Likewise, if you go to the right-hand side picture, you'll see that there are several alcohol groups attached to it, and they are attached to carbon atoms that have different properties. For example, this alcohol group is attached to a carbon atom which is a primary carbon, and that's why this is a primary alcohol group there. Likewise, if the carbon atom is secondary carbon, the alcohol group is secondary alcohol group, and tertiary alcohol group, and so on. The oxygen hybridization and geometry is very important in terms of understanding the alcohol and naming them. Alcohols have a bent shape like that of in H2O or water. The bond angles are very, very similar. And one of the things to keep in mind in this case is that both the carbon-oxygen as well as the oxygen-hydrogen bonds are polar, because oxygen atom is much more electronegative than the carbon or the hydrogen. And the diagrams below at the bottom of the slide show the bond angles or similarity between them. So, having some fundamental concept or idea about alcohol, how do we name them according to the IUPAC rule? The first step that we must follow is to find out what the longest carbon chain in the compound is like. So for example, here I have shown a simple alcohol where I have 1, 2, 3, 4, 5, 6 carbon atoms attached to it. And therefore, the parent compound was N or ANE at the end, alkane. And since now it is an alcohol with one of the hydrogen being replaced by hydroxy group, we simply should end the NE of that to OL or all. So from being hexane, 6 carbon containing alkane or hexane, it becomes 6 carbon containing with an hydroxy group attached to it, hexanol. To continue on that, the next step is that not only we have to identify the longest chain and know how many carbons are there in that chain, but which end to start numbering them from. Our goal is to number the carbon chain in a way so that the hydroxy group gets the lowest number possible. Here I have shown a couple of compounds at the bottom, and they represent the same molecule, and it shows how to name them. So for the compound to the left, first we have to number the carbon chain in a way so that the hydroxy group is attached to the number of a carbon which is lowest possible. We cannot start doing the numbering from the left because then it will get a number 1, 2, 3, 4, fourth carbon. On the other hand, if we start numbering them from the other end, which is 1, 2, 3, it shows that the hydroxy group is attached to carbon number 3. So that is the more appropriate way of numbering it. We also have to keep in mind that if there is an other functional group, such as alkyl group in this case, or a methyl group attached, which carbon number is that, where it is attached to. In this case, simply it happens to be the number 5 carbon, or the 5th carbon. So the number, with the numbering done, we know that the parent alkane or hexane, 6 carbon containing hexane, became hexanol. Not only hexanol, it became hexane 3-ol because the carbon number 3 is attached to the hydroxy group, but also for the fact that it has an alkyl group attached to the 5th carbon, so we'll have to name it according to the IUPAC rule. 5-methyl hexane 3-ol. 5-methyl hexane 3-ol. So those are naming for the alcohols that are straight chain carbon atoms. What if the hydroxy group is attached to a ring? I have shown a couple of rings, and the strategy here is that hydroxy group is bonded to the ring, and therefore because the functional group is, or the hydroxy group is considered to be attached to carbon number 1, we don't usually say number 1. We have to name the other functional groups that are attached to the ring. So in this case, there are 2 compounds I have shown. In one of them, the methyl group is attached to number 3 carbon atom, and in the other one, there are actually 2 alkyl groups. Number 1 carbon is attached to the hydroxy group for both, but the other alkyl groups, such as ethyl group, methyl group, and 2 methyl groups here, we have to name them as well. So this one happens to be 3-methyl cyclohexanol, and the other one is 2, then 1, 2, 3, 1, 2, 3, 4, 5. So 2, and then 5, 5 trimethyl cyclohexanol, because there are 1, 2, 3 tri-methyl groups attached to it. Let's watch this video to learn a little more about how these alcohols are structured and therefore their names. And after watching the video, we will complete an in-class assignment. You can do the in-class assignment with a partner you can choose from the class. And as you work on the assignment, I will go around the class to assure that all of you are on the right track. And if anybody needs any help to complete the assignment, to get better understanding of it, I'm here to re-explain and provide that help.